All right, hi everyone. I'm really excited to be telling you more about App Inventor. If you've been here the past few days, you've probably already heard quite a bit about it, but for those of us joining today, I'll give a very brief overview. So the App Inventor project is a completely free and open source web platform that allows anyone to make mobile apps. And the reason we focus on mobile apps is because they're the most accessible modality for under-resourced populations across the world. So we work with families in really remote areas compared to MIT, where the entire family has one digital device, and that's their smartphone. And that's their gateway to learning more about the digital world and developing those very key skills. So App Inventor has been at MIT for over 10 years now, and it's backed by years of research from MIT and Google. And we see that after just 1 year of learning, students are engaged as creators of technology, not just as consumers. And our mission isn't really just about teaching students how to code or develop apps. Really, it's more about empowering them to create apps that improve their lives and uplift their communities. So we want to engage students in using technology to help themselves and to help the world. And this is kind of what the App Inventor interface looks like. It's a very simple drag and drop interface where you can pull buttons, images, labels onto a screen, design it to look however you want, and then code using a block-based interface, very similar to Scratch, that's also based on Blockly by Google. So Evan gave a great overview of the numbers yesterday, but I'll just deep dive into the last year. We had 11 million learners from across the world, and this has been steadily growing over the pandemic, which I will talk about a bit later. They come from every single country and region in the world, and due to our wonderful volunteers, we've been able to translate App Inventor into 19 different languages. And this really lowers the barrier to entry for a lot of students from places where English isn't their first language. And they don't need to be competent in English to learn how to build computational thinking skills. And we're very proud that half of our students come from the developing world. It really speaks to our mission of empowering those who really need access to these platforms and resources in getting them. So our impact is very global. The US is our #1 user base, but in terms of adoption, Hong Kong is #1. We're used by over 90% of schools in Hong Kong via the Cool Think at Jockey Club program, and it's gotten support from the Education Bureau, so I think it'll be rolled out to all of the schools. Professor Kwong can correct me if I'm wrong. And in the past year, Saudi Arabia has been our #1 growing country. They quadrupled in users in the last year, and they're now #11 in all of our countries and regions. So I'll talk a little bit about our education philosophy, which is really steeped in MIT's ethos. And we really believe that the best way to teach students is to empower them to create personally meaningful and useful artifacts. And I'll read a quote by Seymour Papert here, who we really lean on and created the idea of constructionism. So he said that children learn best when they're actively engaged in constructing something that has personal meaning to them. And we also look towards self-efficacy theory, which is an individual's belief in their ability to do something. And this has over 40 years of research, and it's the strongest ties to task-specific success. And the way we break down self-efficacy is through these 4 buckets, and I'll talk about them in relation to AI and App Inventor. The first and the most important item is an active mastery. So we want students to have successful hands-on experiences building AI and building apps. And to do this, we have these starter App Inventor curricula where in 45 minutes, we take a student from no expectation of any digital creation or coding experience to I've made an app that works on my own phone. And that kind of initial engagement with coding and creation really makes them feel like they can continue and learn more complex skills. The second one is vicarious experiences, which is hearing and seeing people similar to you succeed at these types of activities. So especially when working with students from underrepresented populations, we try to show them other people like them who are AI scientists and developers, and even other students of their age and their background. And 4 and 5 are persuasion and support and physiological experiences. We want students to feel supported by their mentors, their peers, and their community. And through our appathons, if you've judged for them, which I know we have judges in the audience, we actually ask judges to provide both feedback and positive words of encouragement to our students. So we don't want this to be a stressful experience. We want them to learn and have a good time. And we also really lean on computational action, which Professor Mike Tissenbaum wrote, I think, the first paper on a couple of years ago. And the idea is to make computing education more inclusive and empowering. We want students to create something that has direct impact in their lives and can be used. And that leads to formation of digital identity. So we want them to identify as creators of these technologies. So for those of you who are familiar with App Inventor, you might have heard of the App Inventor Foundation on and off for the last 2 years. I'll tell you a little bit about why we created the foundation. So we're a 501c3 nonprofit, and we were created during the pandemic. And that's because, as you can see from this lovely chart here, from 2012 to 2020, so in 8 years, we had 8.2 million cumulative users. And our usage really exploded during the first year of everyone learning at home. So we had 7.5 million that year alone, compared to 8 million for 8 years. And we kept growing from there. So I think the 10-person lab at MIT, we kind of realized that we couldn't support the literally tens of millions of students and teachers who are using App Inventor. And we decided to expand to an organization that can better collaborate and partner with people across the globe. Our main objectives at the foundation are in programs, educational resources, and community partnerships. So for programs, I talked about this a little bit earlier. We want to encourage and celebrate our learners, and we do this through appathons, competitions, and media spotlights. For educational resources, we keep MIT's tradition of creating free and open access curricula for all teachers. It's distributed through Creative Commons. And we're also doing some exciting new programs with teacher training and building communities of best practice to support educators. And for community partnerships, we really want to work with grassroots organizations around the world who know their teacher and student community much better than we do, so we can tailor our workshops and experiences to those communities. And I'll quickly spotlight a few of our programs. I know we're running out of time a little. First, I'd like to talk about the Global AI Hackathon. So this was the first year we ran the Global AI Hackathon, and this was in collaboration with MIT Raise and DP World. And the idea was to get people from across the world to use App Inventor and AI components to create apps for climate, sustainability, health, and wellness. We had over 1,000 participants. The median age was 16, but the youngest was 7 years old, and the most wise was 73 years old. And they came from 91 different countries and regions, and half came from the developing world. And some of them are here today, and they presented last night, so please try to talk to them and meet them. Oh, yeah. And in line with the research we do at MIT, we analyze what AI tools these students used. So 66% used chatbots, and that included ChatGPT, Gemini, Llama. About half used image classification models, mostly Teachable Machine and Personal Image Classifier. And a little bit less than half used speech synthesis and recognition systems. So if you realize something up here, these numbers add up to more than 100%. That means a lot of our student projects were multimodal. And that's something that really excites us about what students are doing and experimenting with regard to AI. And I want to quickly go over some resources we are developing. I'm very excited to have worked with UNESCO for the past 2 years to develop the UN's AI competency framework for students. This is the pre-release version. It'll be formally released in September at the UN Digital Learning Week in Paris, but I'll just give a preview here. So we worked with teachers, researchers, students, and professors across the world for the past 2 years to design this framework. And we wanted it to be inclusive for places where access to the internet is an issue, as well as places where there are lots of resources. So this framework has 3 progression levels: understand, apply, and create, and 4 competency aspects, which are human-centered mindset, ethics of AI, AI techniques and applications, and AI for problem solving. And at the intersection of the aspects and levels are what we call competency blocks. And when this framework is released, we'll be releasing curricular goals as well as recommended activities with this framework. I'll skip this for now. If you want more information, you can come find me after. I also wanted to announce that we're piloting the App Inventor Educator Collaborative this year. We're very excited about this program because teachers have been coming to us saying, I want teacher training, I want to show other teachers in my school App Inventor. And we're partnering with a few organizations to actually start this. So the goal of this program is to build local communities of practice for educators. And this was really heavily inspired by the Cool Thing program, where they trained thousands of teachers across the world, or mostly in Hong Kong, but now expanding across the world, and had those teachers become community leaders to train other teachers. And we're replicating this in 3 US states this year: Massachusetts, Texas, and California. So in addition to the teacher training, curricula development, and establishing a system to foster ambassadors, we're also going to be developing an App Inventor classroom portal. So this is something that teachers have also been asking for years. So teachers will be able to group students in teams, assign assignments, and plug into their gradebook and LMS systems. I wanted to spotlight our partnerships for the last few minutes. So we're very proud to be a part of the AI Forward Alliance, TIFA, which is led by Technovation and includes organizations like UNICEF, Grameen Foundation, McGovern Foundation, Google, and Girl Geek X. And the goal of this partnership is to bridge the gender-based digital divide. So App Inventor is committed to providing teacher training in support of this mission. We've also been working with the Congressional App Challenge for the past 2 years. They're a really wonderful program if you're in the US and haven't heard of them, where the US House of Representatives encourages students from each state to develop apps for civic good. And as I mentioned previously, we're working with UNESCO on the framework. So I will end here, but for my final moment, I would love, if you're a teacher and you work with students from Massachusetts, Texas, and California, particularly students from Title I schools, we'd love to talk to you to be a part of our educator collaborative. And you can reach us on social media, and we also have a mailing list on our website. So thank you so much.